My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 646. In this lecture, we will try to understand forget gate in Lstm. So let's look at this connection. Just try to recall, we discussed about this one. What does this connection do? Let's ignore everything else. What does it do? I have my cell state coming from previous timestamp ct minus 1, isn't it? And I'm sending it to the next timestamp ct, isn't it? Now this output I got from previous stage. This output I'm getting this particular output from previous stage, that is from t minus 1 stage to t stage, isn't it? ct minus 1 is at t minus 1th stage, ct is at tth stage. I have a pointwise this one, just see, this one is pointwise multiplication operation here, and this indicates pointwise multiplication, isn't it? What is this? This is pointwise multiplication operation, which we discussed in previous lecture, isn't it? Here pointwise you also have pointwise addition operation. If my pointwise multiplication operation is a vector of all ones, let me assume, I am assuming my pointwise multiplication operation is a vector of all ones, and if my pointwise addition operation is a vector of all zeros, just try to understand this one. Then what happens? What is our assumption? We are assuming that pointwise multiplication operation is a vector of all ones, and your pointwise addition operation is vector of all zeros. Then what happens? Just say this one. If it is the case, what happens then if these two condition holds? Which conditions? Your pointwise multiplication operation is a vector of all ones, and your pointwise addition operation is vector of all zeros. Then your ct becomes ct minus 1, means there will be no change. There is no change in between ct and ct minus 1. ct minus 1, ct same, isn't it? That's what it says, because whatever vector I got here, in this case what happens, whatever vector I got here, same vector I can see here, means your ct minus 1 and your ct same, they are as it is, isn't it? Because whenever vector I got here, whichever vector I got here, same vector you can find here, isn't it? If I multiply, why are you getting same vector? What's happening? If I multiply every element by 1, actually here what am I doing? I am multiplying every element of this by 1, isn't it? And add zeros. I am multiplying every element of this vector with 1 and adding zeros, means what will you get? Your ct minus will be same as ct, isn't it? If I multiply every element by 1 and add zeros to it, I get the same vector, same elements, this same elements here in both the places, isn't it? Just see, if I multiply every element by 1 and add it 0, and I will get same vector. Here you can see the same vector. Your ct minus 1 will be same as ct. That's what I am highlighting here. Just see, if I multiply every element by 1 and what happens, and add it to 0, what will you get? You will get same vector. I'm repeating this is so what is actually happening here is, whatever the cell state before, means ct minus 1, I can send it out as is, isn't it? Your ct minus 1, I can send, what is the cell state before, means ct minus 1, I can send it as is. I can send it as is if I want to. That is important. If this value I'm sending, just say your ct minus will be same as your ct. If this value I'm sending all ones, this value I'm sending here all, here I'm keeping all ones. Just see this one. This is all ones. This is all zeros, here all zeros. Then whatever the value of ct minus 1 is same vector, literally it will copy it to the ct. Your ct minus 1 will be same as ct. this is like an identity of, this is like an identity. This becomes your ct minus 1 is same as ct means what does it mean? This becomes like an identity. This becomes like an identity if and only if what happens, this becomes like an identity if and only if the input that we get from here, yes, the input you are getting, whatever the input you are getting from here, this input is called, let me say this input is ft. Ft is, what is ft? Ft is vectors of 1, all ones. The input that you get here, the input that you get here is zeros. The input that you get ft, that ft I am assuming all ones. The input I am getting here, I am assuming all 0. Whatever I have here, in this case whatever I have here, in this case whatever I have here, same thing will be copied. Means your ct minus 1 is same as ct. Whatever I have here is same as this. Means what is that map? That map is known as identity map. We have done something similar. Remember our rest nets, or I can say residual nets in convolutional neural networks. What did we do in rest nets? You have these connections, isn't it? You just try to recall residual networks in convolutional networks. You have these connections, but there is a way to jump from here to here. Just see, there is a way to jump from here to here, isn't it? Just try to recall rest nets which we discussed in convolutional neural networks. I can skip even layers through an identity. This was called as residual unit. We were saying that it's called as residual unit or the residual block or identity block. Recall what we learned in ResNet. What did we do? We had a mechanism for us. We had a mechanism where I can jump over layers and just transfer what we did. There is an identity, just transfer the whole identity. So what I first learned about LSTMs, there is an identity mapping possible in ResNet, just like sorry pardon. So what I first learned about LSTMs, I saw a lot of similarity. I can say there is a lot of similarity between what ResNets were achieving and what LSTMs was doing, because this is an identity mapping. But of course LSTMs is far more complex. If you speak strictly, LSTMs are far more complex, because you have point wise something like you have point wise multiplication, point wise product, and point wise multiplication addition, which you don't have in ResNets, where you have weights. But I saw that there is an identity mapping possible in ResNets. There is that's what I'm saying here. There is an identity mapping possible in ResNets, like your like your LSTMs. I request you to go through what we discussed in ResNets. We discussed those ResNets as a part of convolutional neural networks long back, isn't it? Anyway, let me come back to the original discussions. LSTM. So what's happening here? State of the LSTM state of the LSTM one time step to one time step means CT one time step to another time step, CT minus 1 to other time step CT can be carried as is if I want. That's important. If I want, without changes. If I want to change, if I want to change it, I can change it, isn't it? Suppose I have a vector here. Let me assume I have vector 2, 3, 4, 6, 8. Suppose this vector here is all ft. I am assuming my ft. Suppose the vector ft is all halves, 1 by 2, 1 by 2, something like. The vector here is at point wise addition, means I am assuming this vector is all zeros. Then my CT becomes my CT. Your CT minus 1. What is this? This is CT minus 1. Which one is CT minus 1? Just say this one. This is CT minus 1. Isn't it? Now in this case, now your CT becomes half of this. I will get half of this 2, 3, 4, 6, 8. So I can decide how much of my what am I doing here? Point wise multiplication and point wise addition. Point wise multiplication means what? 2 into 1 by 2, that is 1, plus 0, you are getting 1. Point wise multiplication. And 3 into 1 by 2, that is 3 by 2, 1.5 plus 0, 1.5 plus 0 means 1.5, means you are applying point wise multiplication and point wise addition. In that case, my CT becomes half of this CT minus 1. I will get half of this. So I can decide. What does it mean? I can decide how much my previous cell state. That's important here. How much my previous cell state do I want to remember to the next state. That's what this FT tells me. This FT tells me how much of previous state, what percentage of the previous state remember to the next state. This is literally like forget gate. This is for how much I can forget, isn't it? How much I remember, I can say how much I remember or how much I can forget. If it all once, if your FT is all once, if it is all once, you are remembering everything, isn't it? Wherever whatever is here, if you keep FT equal to all ones, what happens if you keep FT equal to ones? If you keep FT equal to whatever is here, that will be reproduced. You can send same thing, isn't it? Whatever is in CT, you can remember everything to CT from CT minus 1 to CT. Whatever is in CT minus 1, that will be sent as it is to CT if your FT is vector of all ones, isn't it? This what is this? We already discussed this. This one. What is this? Is often called as this FT. This FT is often called as this FT. I can say often called as forget gate, isn't it? This is known as. This is called this particular gate. This one is this gate. This one is called as, this particular gate is called as this into point-wise multiplication. I can say that point-wise multiplication is called as forget gate because it tells you, it gates how much information should go from CT minus 1 to CT, isn't it? From previous stage to next stage, or what percentage of information should go from CT minus 1 to CT. Here this plus operation, this is point-wise addition operation. This how much information can I add? What it indicates here, you are plus point-wise addition plus adding more information to the cell state. I request you to go through. This is known as forget gate. This particular thing is known as forget gate. This one is which is useful for adding more information to the previous cell state. I request you to go through this lecture. I will continue my discussion on Lstms in my next lecture also. Thank you very much.